Experiment 6 is design of multiplexer and demultiplexer. The objective is to design verilog code for 4 into 1 multiplexer and 1:4 demultiplexer and verify its functionality. The tool here used is Modelsim. So multiplexer and demultiplexer. So multiplexer is a combinational circuit that uses data input to generate single output, and demultiplexer is also a combination circuit that uses single input that can be directed through multiple outputs. So here it is the multiplexer and demultiplexer. So multiplexer is a device that can receive multiple input signals and synthesize single output. So if the number of input is n, then the select inputs is n, then the number of input is 2 to the power n. So here if it is number of input is 2, if the select input is 1, the number of input is 2 to the power 1, so it is 2. If the select input is 2, the number of inputs will be 2 to the power 2, so it will be 4. And if the select input lines are 3, the number of inputs is 2 to the power 3, so that will be 8. And for all it will be only single output. So here there is 2 into 1 multiplexer. So here one select input line is there, 2 input and 1 output is there. So for select line, if it is 0, the output will be 0. If the select line input line is, if the enable is 0, everything will be 0. The enable should be 1, only then our multiplexer will work. So if the select line is 0 and the D0 is on, only then there will be output. So the SOP for that will be S dash into D0. Then enable is 1, select input line is 1 and the D1 is on, only then there will be output. So the SOP for that will be S into D1. So total SOP will be S dash plus D0 plus S into D1. So this is the circuit diagram for 2 into 1 multiplexer. For 4 it will be 2 select input lines, 4 input lines and the output will be 1. So if the combination is 0 0, D0 should be on, then only our output will be 1. For 0 1, D1 should be on. For 1 0, D2 should be on, and for 1 1, D3 should be on. So these are the SOP we got, and through the SOPs we will get this circuit. So this is the equation for 0 0 D0, 0 1 D1 plus 1 0 D2 plus 1 1 D3. So for 8 also the equations will be similar. So this is the gate level modeling of 4:1 multiplexer in gate level. So we have put all the equations, and finally all the AND inputs we will do with the OR to get our SOP. So this is the gate level modeling. We will simulate it in Modelsim. So Modelsim, we will go to add project, new file. We will write MUX 4:1 and the file type will be verilog. We'll press OK and double click for writing the program. We'll write the program, we'll save it and then we will compile it. So we can see the compilation is successful. Then we will go to simulate, start simulation, we'll press expand the work and the name is MUX 4:1. So here we'll click on that, gate level, we'll press OK. All this will open. So we will only put the input and output. So Y, A, B, C, D, S0, S1 and others are wires, so we will not add that. So we will add wire. The waveform window is open. We will give the input. So input is S0, S1, so we will add, we'll give the clock 50, S0 we will add it as 100. Here we will take it as 1000 nanosecond. Here also we have to give the input, so A we will give it as 25, this we will give it as 50, B, C we will give it as 100, and for D we will give it as 200. And save this and we will run it. So here we can see Y is the output. So here when all the conditions are fulfilled, only then we will get the output. So for 0 0, if D is on, only then we are getting an output. Here we will see another condition, 0 0 0, A is on, sorry, here 0 0 and A is on, only then we are getting an output. Here also same condition, 0 0 and A is on, only then we are getting an output. Here 1 1 is there, so 1 1, if D is on, then only we will get the output. Here also D is on, then only we are getting an output. Here also 0 0 condition is there. So for the conditions, only for these conditions we will get the output. For 0 0, if D 0 is, A is on, only then we will get an output. If 1 1, D is on, only then we will get the output. So this is the gate level modeling. In data level modeling, we will write the whole equation into one line, Y equal to whole equation. So this is the data flow modeling. So close this. Simulation will end the simulation. That